Students, welcome to our video lecture. Our today's topic is trigonometric equations and its solution set. Now, by this time, I hope that all of you would have studied the basic formulas very perfectly, memorized the formulas, and even you should know the application of basic formulas. Now, let us start with the definition of trigonometric equations. Suppose I write an equality in this form: sin square x plus 3 cos x minus 7 is equal to 0. Then this equality is a trigonometric equation. An equality involving two or more trigonometric functions is called, students, a trigonometric equation. An equality involving two or more trigonometric functions is called a trigonometric equation. Clear, students? This is the definition. Now, students, I am dealing with one, you can say, extra topic, which is principal period. Now, students, suppose I draw the graph of sine function. Say this is 0, pi, 2 pi, 3 pi, 4 pi. Now, whatever graph is there between 0 to 2 pi, same graph is there between 2 pi to 4 pi. So, graph of all t functions repeat after a certain interval, and that interval is called principal period. So, principal period of sine and cosine functions is 2 pi, and even cosec and sec function is 2 pi, and principal period of tan and cot functions is pi. Means what? The graph of tan and cot functions repeat after an interval of, students, pi. So, principal period as a topic, as a different individual topic, is not included in our syllabus. In old textbook, in old format of textbook, principal period was there, but for your knowledge, you have to only remember principal period of sine and cosine functions is 2 pi, principal period of tan and cot function is pi. Means what? The graph of that function repeats after that much interval in terms of angle. So, students, we have to be very careful when we are dealing with solutions of trigonometric equations. Now, students, our next point is solutions of trigonometric equations. So, having done the definition of trigonometric equations, principal period. Now, students, all of you concentrate how we deal with solutions of trigonometric equations. Our next topic is to deal with solutions of trigonometric equations. Students, our first formula is solution set of, let us go as per the textbook. It is given solution set of the equation sin x is equal to sine y. Whenever, students, we have to find solution or solution set of any trigonometric equation, it should be written in this form. Then, students, the solution set is x is equal to n pi plus minus 1 raised to n into y, where n belongs to set. N is always, students, an integer, and students, set of zeros of sine function. I think in a table I have explained you all the basics. So set of zeros of sine function, sine x is equal to 0 implies x is equal to n pi, where n belongs to z. This is set of zeros of sine function. Then, students, our next formula is solution set of the equation cos x is equal to cos y. This is our, students, next you can say solution set of the equation cos x is equal to cos y. Here the solution set is x is equal to 2n pi plus or minus y, where n belongs to set. And set of zeros of cos function cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2, where n belongs to set. Divison has taught you this even in the trigonometric table, students, which I have already informed before. We have written this. Then, students, the solution set of the equation, solution set of the equation 10x is equal to 10 is x is equal to n pi plus y, where n belongs to z, and set of zeros of 10 function is same as sine function. So n pi, where n belongs to z. Now, the most important thing, students, is that we have not written solution sets of cosec, sec and cot, which are respectively the reciprocal functions of sine, cos and tan. The logic is that we can convert cosec to sine, we can convert sec to cos, and we can convert cot to tan. So we need not write solution sets of all t functions, even if we write solution set of sine, cos and tan functions. This is sufficient. Now, students, solution set means there can be more than one solution of a trigonometric equation. So we are writing solution set, and solution in the range, students, pay attention, solution in the range, solution in the range close to 0 to open interval 2 pi is called principal solution. Whenever you have solution in the range 0 close to open 2 pi, means all four quadrants covered once, that solution is called principal solution of trigonometric equation. It is called which solution, students? Principal solution of trigonometric equation. And for your understanding, all trigonometric equation may have many solutions. So the solutions involving n is called general solution, and the solution in the range close to 0 open interval 2 pi. Students, that solution is called principal solution. So this one, students, we should carefully remember and memorize before doing the sums of solutions of trigonometric equation. So general solution also we require, principal solution also we require, and we also require set of zeros of sine function, cosine function and tan function, including range also. So that table which I have already discussed in the previous lectures, that table, students, T table, is very, very important. Now students, we are discussing few sums of exercise 3.4. Find the general solution as well as principal solution of the given trigonometric equation. Okay, the first is tan x is equal to 3. Exercise 3.4, sum number 1. Tan x is equal to root 3. Now, students, what is the traditional method to solve trigonometric equation? I told you, a given trigonometric equations may have more than one solution. That is why we had solution set. Two types of solutions of trigonometric equations exist. One is general solution and other is principal solution. A solution involving n, these all solutions which we have written. Solutions involving n is called general solution. GS, I write it here. GS means general solution, and PS means principal solution. So in the sums you will be asked, students, either to find general solution or to find principal solution. Based on general solution, very easily, students, we can derive the principal solutions. So please all of you pay attention. Now the first step is to modify the given equation in the form tan x is equal to tan y. If it is a tan function, cos function, then cos x is equal to cos y, and sine function, then sin x is equal to sin y. So in any sum of trigonometric equation, the first step is to convert the respective t equation in the standard form. So my right hand side is a number, that number I have to convert in terms of tan. In tan, root 3 we get at tan 60, and 60 degree is nothing but pi by 3 area. So we have converted this equation tan x is equal to root 3 in the form, students, tan x is equal to tan y. Now we write the general solution. The general solution is x is equal to n pi plus y. Our y is nothing but pi by 3. So general solution of this equation will be x is equal to n pi plus y, where n belongs to z, and our y is nothing but, students, pi by 3. Our y is nothing but pi by 3. I hope now all of you would have easily understood this. So this is general solution. Now to find principal solution, we always take some definite values of n, and n is an integer, so n can assume value 1, 2, 3, 4 up to positive infinity, minus 1, minus 2, minus 3 up to negative infinity, including 0, because 0 is also an integer. So usually to get principal solution, we have to take n in the range of minus 3 to plus 3 maximum. So suppose I take n is equal to 0. Then I get x is equal to 0 plus pi by 3, and which is pi by 3 belongs to close 0 to open to pi. Then when n is equal to 1, I get x is equal to pi plus pi by 3, and that is equal to 4 pi by 3. Negative values we don't have to consider, because when I take n as negative, I am going to get negative answer. But when I take n is equal to 2, it becomes 2 pi plus pi by 3. X means extending 2 pi, we don't have any principal solution. So the principal solutions are pi by 3 and 4 pi by 3. Clear, students? All of you understood? So solutions which are in the range of close to 0 to open to pi are called principal solutions. So this is our general solution, and this is our principal solutions. This is our answer. So trigonometric equations are very easy to understand once you develop the concepts. Okay, let us do the second exercise 3.4, students. I am doing sum number 2. It is sec x is equal to 2. Okay. Second question, sec x is equal to 2. Students, we have not written the solution set of sec function. I have already explained. Sec is converted to cos, so cos x is nothing but 1 by 2. So now I have to convert this equation in the form cos x is equal to cos y. We have to convert this equation in the form cos x is equal to cos y. Now in cos, when your right hand side number is positive, acute, and when right hand side number is negative, we have to write obtuse angle. Never forget this. In cos, when right hand side is positive, now in cos at what angle I get 1 by 2, then I can say this is equal to cos pi by 3. If this was minus 1 by 2, I would have written pi minus pi by 3, which is 2 pi by 3. So right hand side number has lot of significance in the sums of students trigonometric equations. Now here y is nothing but pi by 3. So the general solution, when I am going to write general solution, will be x is equal to 2 pi plus or minus y, where y is pi by 3, and students n belongs to set. N belongs to set. So this is the general solution. Now for principal solutions, you have to understand this is plus as well as minus. X is 2 pi plus pi by 3 as well as x is 2 pi minus pi by 3. Both the ways. So when I take n is equal to 0, I will get x is equal to pi by 3 here, and here I will get minus pi by 3. Minus pi by 3 does not fall of principal solution. For principal solution, our value of x must fall in the closed interval 0 to interval 2 pi. Then when I take n is equal to 1, this will be 2 pi plus pi by 3 excluded. Here it will be, when I take n is equal to 1, here I will get 2 pi minus pi by 3, which is 6 minus 5 pi by 3. So either we get answer from plus part of solution set, or we get answer from minus part of solution set. But the condition and criteria is that it should fall within the range close to 0 to open interval 2 pi. So here it doesn't fall. If I take 2, then this will be 4 pi minus pi by 3, which is extended above 2 pi, and here definitely. So the principal solutions are pi by 3 and 5 pi by 3, and this is the general solution. So this type of sums are very easy, students. Trigonometric equation, the algorithm to solve the type of sum is to convert the given equation in the form of sin x is equal to sin y if it is a sine function, cos x is equal to cos y if it is a cos function, and tan x is equal to tan if it is a tan function. Same, students, equation cos x is equal to 1 by 2, example 21 is given in the textbook. So for today's lecture, I advise you to write and memorize these formulas. These formulas are key concepts for exercise 3.4. Trigonometric table, which I have already explained you, and I told you we should write trigonometric table till 31st August till we complete the chapter. So remaining concepts of this trigonometric equation, students, I will take in the next lecture. So I hope all of you have understood the basic theories. Remember this also, the principal period of sine and cosine functions is 2 pi. It means graph of sine and cosine functions is repeated after an interval of 2 pi. And principal period of tan and cot function is pi. It indicates that graph of tan and cot function is repeated after an interval of pi. And same way, principal period of sec and cosine functions is also 2 pi. Okay, students. Now concentrate. This sums also need to do twice. This problem is also right. The remaining, students, we will continue in the next lecture, and in the next lecture I think students will complete exercise 3.4. Remaining questions we will do in the next lecture. Okay, students? So we conclude.